Everyone knows about the three states of matter: solid, liquid, and gas. If you're a huge nerd like me, you know all about plasma, the fourth state of matter. But what very few people know about is there's actually a fifth state of matter. And this last one is the most extreme, the most cold, and the most strange. It's called the Bose-Einstein condensate. In order to learn about it, you first need to know a little bit of quantum mechanics. Quantum mechanics, which is just a field of science describing really tiny things, like atoms and subatomic particles, is inherently probabilistic. This means that instead of describing a particle as having a certain position, it'll describe it as having a certain chance to be in any position. In fact, you can represent the probability that a particle is in any set of positions by drawing a curve. And the area under that curve at any point in time is the chance that a particle will be there if measured. This curve, called wave function, is actually what defines the particle between measurements, not a particle bouncing around that we just use to describe using statistics. It's actually that wave. Quantum mechanics also has a principle called the uncertainty principle, which says that if you know the momentum of a particle very precisely, then you can't possibly know its position precisely. Now here's where it gets interesting, because temperature is just basically a measure of how fast all the particles in a certain substance are moving. So if you get a very slow temperature, all of the particles move very, very slowly. So within like a millionth of a degree of absolute zero, particles are basically standing still and not moving at all. But this means that their position is very spread out and wide, because we know their momentum. They're standing still. They have basically no momentum, which is a very, very precise momentum. Therefore, we can't know their position. They have a very spread out and undefined position. But this means that, you know the wave function I was talking to you about earlier that describes where a particle will be? The wave functions of more than one particle can interact and add together, in fact. And if you add up enough of these particles in an extremely cold substance, they can all add together to start acting like a gigantic quantum atom at a size that's actually understandable to us. It's no longer nanoscopic, it's at the size of everyday life. So we can observe the strangeness and weirdness of quantum mechanics at these extremely low temperatures, because the particles are almost literally combining into a single giant particle, which is insane and incredible, and can only happen at these extremely low temperatures, because we need to know the exact momentum of every single particle. This means that it's one of the strangest forms of matter anywhere, because it exhibits these strange quantum behaviors, like being fully based on probability, at a scale where almost nothing is. Newtonian physics, which is probably the physics you're learning in high school, like F equals ma, isn't probabilistic at all. However, if you go into those extreme regions of cold, Newtonian physics and most of our understanding of the universe goes out the door, and all we have is quantum probability, which is amazing. Thanks for watching.